Welcome. Today's experiment is analysis of dataset with classifiers. So we are going to design our own dataset and random dataset and create classification. So tasks are to create a dataset, create datasets and assign the label to the dataset. Randomly we assign either 0 or 1. Compute conditional probability density function using Gaussian probabilistic density function. Compute posterior probability, design Bayesian classifier, and compute the performance measures, accuracy and classification error using Bayes classifier. So posterior probability formula is Qi of x is Pi of prior Wi of x. Prior probability is P of Wi. Conditional density function Qi is equal to, conditional density function is prior probability into P of x given Wi, posterior probability, divided by Z, the likelihood function. Posterior is equal to prior into conditional probability divided by likelihood. This is the formula for Bayesian theorem. We are going to use this. Z is equal to, Z likelihood function is sum of all P of Wi and P of x given Wi. H of x is equal to 1 if Q1 is greater than Q0 of x, and 0 if Q0 is greater than Q1. So we generate the random matrix m of size m comma n. It's a matrix, and G rand of n, mn is the size, and ms Gaussian distribution is 10. We find mean, S is the skewness, P of x is 1 by 2 pi whole power d by 2 mod s power half x power minus half into x minus mean whole transpose S inverse, skewness matrix S inverse of x minus mu. So program 1, we'll go for the Scilab, and I've typed the programs here. So this one is generating a random data set. So seed 0, m is 0 comma 0, s the data is 1 0 and 0 1, skewness value. Number of data sets is 500, number of data points. So x is equal to generate multivariate normal random variable G rand of n, mean m must be of m cross 1 column vector, m cross m data we generate, and then plot the data. So figure 1, plot x1 for first row all columns and second row all columns with dot. In same way plot different data sets. We have nearly 8 data sets here to be plotted. In the same way we find random data sets there. So we run the program. So we get all the data set points, 8 random data set points we have plotted here. It's an example. So next program is to generate the data set as the vector containing the labels. We are going to do the data set with labels also. That is program 2. First one we didn't create labels for the data set. So now same way 100 so 100 data set we are doing. The dimensional of the data L is equal to 2, x is equal to 3 cross 3, 3 slash inverse. So in that so we are going, y1 is minus 1s of 1 comma n1. So y1 can be maybe either minus 1s of or 1s of, and we plot it with dot r and a dot, red and a dot. So when we run it, so the data sets are created. Some of the data sets, some random data sets are dot with r, and some random data sets are a circle with blue. Then we go for the this one comp. So we're going to do the Bayesian estimate, as I said. So for Bayesian estimate we have the function here Bayes underscore classifier. So before doing the Bayes under classifier, inside the Bayes classifier we need to find the Gaussian density function first. So L comma size. So save this file with the function name. So this is the function name. Save the file with function name dot sce, and the input variables are m, s and x, mean value, skewness value, and the input data point value. The output is z. Z is equal to, we use the Gaussian formula 1 by 2 pi, that equation formula is used here. So this comp Gauss density value, this function is called in this Bayesian classifier function. So save this function by the name Bayes classifier. The input variables are mean, skewness value, probability value, and x value, and the output is z. So we do the Gaussian density function for this x value. Then so this is, we have the same as the second experiment. We have the data points, L is equal to the dimensionality and y1. So till this is same as the second experiment. We have created the random data set with labels. The labels are y1. We plot the data set with b and circle for y is equal to 1. For all the output 1, we save it as b and circle. For the output -1, the class label -1, we save it, we plot it as r and a dot, red color, a small dot. And then m standard skewness value is given. So do the Bayes classification. We call the Bayes classifier with the input variables mean, skewness, s and p. So Bayesian classifier is done, and we display the values for percentage error and accuracy. Accuracy is the correct classification divided by length, and error is 1 minus the correct classification divided by the length. So when we need to run the comp Bayesian classification also, you will be getting an error in the console only. Then execute it. Then Bayes classifier also